So now that we understand the things that are necessary for life and where we should look, let's start talking about the possibility of life in our own solar system. So we know that there's life on Earth, but could there be life on other objects within our solar system? Well, remember we've talked about follow the water. As we mentioned previously, when we talked about Mars, it shows evidence that there at least used to be large amounts of liquid water. And if there was a lot of liquid water for an extended period, then maybe Mars could have life. So evidence that Mars once had liquid water, we see large outcrops of sedimentary rock. And the type of sedimentary rock we see is consistent with a large body of water having sediment settle for long periods of time. We see this sort of feature all the time on the Earth, and this suggests that Mars once had liquid water. We've also found minerals that only form in ground that has been saturated with liquid water. For example, gray hematite. So again, this suggests that there may have been liquid water once on Mars. Now, based off of current evidence, this was around 4 billion years ago, so a very long time. But if there's liquid water, then we have the potential that Mars once had life. In the 1970s, we sent the Viking landers to Mars to study the Martian soil and other aspects. One of the experiments that these had was to actually search for life. The way it did this was by adding nutrients and looking for signs of respiration, the chemical changes that are caused by biological life. At first, all of these experiments actually looked very promising. We saw the exact type of chemical changes in the nutrients that we'd expect if there were little microbes doing their thing. Unfortunately, we didn't exactly understand the chemical makeup of the soil at the time. Since then, we've learned that there are lots of very reactive chemicals in the Martian soil, and that these chemicals can react with the types of nutrients that we added in a way that would look like life, but there was no life. It was just simple chemical reactions. Now, all of that being said, some of the lead investigators of these experiments are still convinced to this day that they actually did find signs of life. It's an ongoing question, but the general accepted explanation is that it was just a chemical reaction, no life necessary. The Viking orbiter, which was taking images of the surface of Mars after the landers had landed, took this image on one particular area of Mars. As you can tell, it kind of looks like a face. This actually led to some widespread speculation that maybe Mars didn't just have life, it may have had complex, organic, intelligent life at some point in the past. Okay, the thinking actually goes that maybe this civilization realized that Mars was a dying planet, that it wasn't going to be able to support their type of life for much longer, so they actually built this face as a monument to declare to some future race that they actually did exist. Here's the exact same feature taken by the Mars Global Surveyor in 1998. As you can tell, under different lighting conditions and at a different angle, it is not actually a face. It is just a natural hill formation. There is no civilization. Now, although we didn't find a constructed face on Mars, the Mars Global Surveyor did find a smiley face on Mars. But as you can tell, this is just natural consequence of how it is that meteorites have landed. So, again, probably no Martian civilization. One of the very best ways to find out if there was life is sample return. That's where we go, get parts of whatever it is we're looking at, and then bring it back to the Earth where we've got our big, heavy, expensive, super sensitive equipment that we wouldn't actually be able to send there. Although we have actually never yet had a sample return mission to Mars, there are some in the works and being planned, but we haven't had one yet. That doesn't mean we don't actually have any pieces of Mars. So what can happen is if a planet gets hit really hard by a meteorite, then chunks of that planet can then get ejected out into space, which means they'll float around for a while and then can eventually land on another planet. In this way, we actually have somewhere around 30 meteorites that we believe actually originated from Mars. We've got about the same number that we think came from Venus, and a little while ago we actually found the first one that we think came from Mercury. So although we don't have sample return missions to any of these things, we do appear to have samples of them. One of these, labeled ALH84001, this is the catalog designation, dates to about 4 billion years ago. This is right during the time where we expect Mars to have had liquid water. Well, as this meteorite has been studied, we have found some very interesting things. For example, we have found these structures that kind of appear to be fossilized microorganisms. We've also found iron sulfide and magnetite crystals, which are both minerals known to be produced through microbial action. We've also found organic compounds that are consistent with the decay of bacterial life. So all of this evidence has led some scientists to claim that this really is a fossilized Martian bacterium, that Mars absolutely did have life at one point in the past. Other scientists have pointed out that every single one of these things can actually be reproduced through natural chemical and geological processes with no life necessary. So, generally, people agree that no, this is not actually a Martian microbe, that Mars has not actually had life. But we do keep finding these tantalizing hints and possibilities, so we're not ready to say no, it's absolutely not. But it's an ongoing question. Now, as we've talked about previously, the Jupiter's moon Europa likely has a subsurface liquid water ocean. This ocean is kept from freezing due to tidal heating. So as Europa goes around Jupiter, it gets stretched and relaxed because of the different distances from Jupiter. This keeps the interior warm enough to actually have liquid water oceans. And if there's liquid water, we have a chance for life. Now, the life that we'd expect in Europa is probably very different from what we'd expect here on the Earth or even Mars. In this case, it'll probably be similar to what we find around black smokers, these deep underwater volcanoes. So life that is actually using the heat of Mars, using the heat of Europa itself as its energy source. Now, occasionally there are missions that are proposed to actually go and drill through the ice to look for life on Europa. Unfortunately, we don't yet have the technological know-how to actually do this. We have some very clever ideas and possibilities of how to do this, but nothing that's been tested and that we've proven will actually work. Now, all that being said, there's actually a mission referred to as the Europa Clipper mission that is going to be sent to Europa to study its surface, look for possible signs of life through geysers, and also try to determine a good landing spot for a possible future mission. So although we don't have tons of information on Europa yet, we're hoping to fix that soon. Alright, here is our fourth clicker question. We have confirmed evidence of extraterrestrial life, meaning what we mean by confirmed is that we absolutely know, or that a majority of scientists agree that we have evidence that we have evidence for extraterrestrial life. A, true, B, false. Go ahead and think about it, and we'll discuss in just a bit. Alright, so the correct answer is false. We do not have confirmed evidence. We have tantalizing hints and possibilities, but everything that we've ever seen can be shown to be caused either by natural chemical or geological processes with no life necessary. So no, we do not have confirmed evidence of extraterrestrial life. The answer is B, false.